Welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, we are here on day 7 where we are going to take a look at today's problem statement. The title says maximum product of splitted binary tree. Given the root of a binary tree, split the binary tree into two subtrees by removing one edge such that the product of sums of subtrees is maximized. Return the maximum product of the sums of two subtrees. Since the answer may be too large, return it modulo 10 power 9 plus 7. Note that you need to maximize the answer before taking the mod and not after taking it. Okay, so we have given a binary tree and we can remove any one edge. When we remove one edge, the tree is split into two subtrees. Now we have to find the sum of all the elements present in each subtree and we have to return the maximum product. So 11 into 10 is 1110. Sorry, 110. Okay, so let us take a look at the constraints. The constraints are the node value contains all positive integers. Okay, and it is in the 10 power 4. Similarly, the total number of nodes is also 10 power 4. Okay, now whenever such problem arises, since it is based on a binary tree, so one hint I would like to give you all is binary tree problems are mostly recursion based. Either you have to go level order, either you have to use BFS, DFS, or mostly using these two techniques only, we should be able to solve such problems. Recursion is very important. So before solving any questions on binary tree, you should be aware of the basic fundamentals of recursion. Okay, now let us try to come to the approach for solving this. If you carefully observe, we have to return the maximum product. Now, as of now, we don't know which by removing which edge we will get the maximum product. We can try with this. We can try by removing this edge. We can try removing this edge, this. But whatever the answer is, we don't know, right? It can come across all. So whenever you are not sure by removing which edge there might be the maximum answer. Let us try with all the removing each and every possible edge. So now you might carefully observe if we have somehow have the sum of all the elements in the tree and let's say we remove this edge. What does this mean? So we are separating this edge and if we are having the sum of these subtree somehow, so how can we get the sum of the rest by simply subtracting the sum of this from the sum of all? Can we get it? Yes. So for example, here the total sum is 1 plus 2 plus 3, 6 plus 4, 10 plus 5, 15 plus 6, 21. The total sum is 21. Now, if I want to break from here, so this is getting separated, right? And the total sum of all the elements in this tree is 4 plus 2, 6 plus 5 is 5 plus 2, 7 plus 4 is 11. So what is the sum of other? It's 21 minus 11, is it? So somehow the approach that is coming to mind is first calculate the sum of all the elements in the tree. Then at each point, we try to calculate the sum of all the elements present beneath it and try to check the maximum product if it is available by multiplying with two numbers. The first is the sum of the current subtree and the rest can be calculated using this. Okay, the problem statement is very simple. Once you are clear with the approach coding it, this doesn't take much more time. Now first we need sum of all element. right? I will write the code in such a way you will easily understand it. Okay, now for now, let us assume this is one function which gives me the total sum. Now, what I want from this, if once I am having the total sum, I need to go on each element and try to find the sum below them and calculate the maximum product. So I try to find another answer, another function, get max product. Okay, and let me define one maximum initially assigned to int min, the most least number available, and return the maximum. Okay, we will update our answer into this. Now, int, sorry. Now we have to let us try to write the definition for this get sum first. Okay. Now the base. This is the recursive base condition. If the root doesn't exist, I can simply return the 0. What else? Otherwise, I can simply return the in order to find. So this is a very standard recursion problem to find the sum of all the elements. So what I can do is I want to find the sum, right? So let's say I'm calculating for this. So I'm at first root. So return root arrow val plus I want to find the total sum of elements starting from its left. Similarly, I want to find the sum of all the elements starting towards right. Okay. So this simple recursion would give me the maximum, the sum of all the elements in the tree. Cool. Now we have this value populated with us. Now using this, let us try to find the maximum product. Again, for getting the max product, we need to start from the root and let us pass this sum value to the function. Good. Now, the way in which we figured out sum, this is the recursive code. It initially goes to root, then goes to the left, and again from this it goes to the left. Again here there is no left and right, so this returns 4. This returns 2 plus 4 plus 5. So 5 plus 4, 9 plus 2 is 11. So this 2 returns 11. Now similar happens for the right part. So this is the recursive step. So likewise we have to go recursive in this function as well. Now if I want to, so this product function, this is similar to find sum. The recursive step is similar. Let us do one thing. Let us add the base condition. Now I want the left sum with me. Other, yeah, left sum is basically the value that I will get when I will go to the left. The sum all goes as it is. Similarly, the right sum will be okay. Now Current sum is nothing but root arrow left plus left sum plus right sum. Okay. Now in so let us take long for product. Let's try to find the current product. If I am at this point, what is the current product? Current product is, so this is the current tree sum. Okay. What is the other tree sum? Is basically sum of all minus current tree. Is it? Let's take this a long because it might exceed the range. Okay. So now let us try to find the current prod. Current prod is nothing but current tree sum multiplied by other tree sum. Okay. And since this is similar to the find sum, it will return the current tree sum only. Okay. Now, whenever we are fetching the current prod, we can update our maxi. So this is our maxi, which is in the public space. I can access it here. Max of the current maxi or current prod. Okay, cool. And while returning at the end, it is mentioned that we have to return modulo 10 power 9 plus 7. So modulo 3, 4, 5, 6, 7, 8, 7. Okay, like that. Yes, I think it should work. Let us try to run this. Okay, we got some error. Whenever we are receiving error, it's good. We can learn from the errors. The long current tree is okay. Root arrow left. Okay, it should be root arrow well. Okay, yeah. We are returning the long. It should be long. We are not receiving anything here. It's fine. It works. No matching call to max. So current prod is our long. Maxi is int min. So we have to make it long. Yes. So sample test cases are passing. Let us try to submit for hidden test cases. And yes, so we are successfully able to solve all the hidden cases. So this is the problem. If you're having any doubt in understanding the approach or with the code, please do let me know in the comments. I would be happy to help. Thank you.